Hi guys! Welcome back to Clinical Chemistry, and our topic for today is arterial blood gases and gas exchange. And this time, magiging very bookish ako dahil isa ito sa mga mahirap na topic sa board exam. In reality, kukunti lang yung na-encounter namin na question sa board exam from this topic. Pero, ginagamit to lagi sa ospital, no? Laging may order na ABG dyan ang mga doctors, and you must know how to interpret the results. So first, balikan natin ang ating mga topics sa biochemistry. So, ano ang difference between acid and a base? So, acid is supposedly a substance with hydrogen content. And paano sinusulat ang hydrogen? Diba? H and positive yan. While yung base is a substance that can contain hydroxyl ions or yung OH negative. Just ito yan. So, yun yung basic difference between an acid and a base. Well, meron tayong another term na ang tawag natin is dissociation constant, or also known as constant value, or pag sinulat in formula, K, pwede rin, may makikita ka rin sa ibang book na Ka or Kb. So, pare-parehas lang yan. Okay? And this is a term that refers to the ability of the acid and bases to dissociate in water specifically. So, anong ibig sabihin nito? So, saan ginagamit ang dissociation constant? So, for example, in this picture, hydrochloric acid in water. So, sorry for the drawing, okay? So, masasabi natin na strong acid si hydrochloric acid if ever na kaya mag-dissociate easily ng hydrogen and the chloride anion. So, madali silang maghiwalay. So, ito yung basis ng pagiging strong acid nito. And the dissociation constant is equal to or more than 0. So, for the formula, no, ipipicture natin sila as ganito. So, for the hydrochloric acid, again, ano ang content natin? Hydrogen ion plus chloride. And the formula for dissociation constant is to take note of the contents of the hydrogen plus the contents of the chloride over the overall content of the hydrochloric acid. And for example, no, in this answer, meron tayong final answer na 10 raised to the 8th power. And you will take note the exponent. Okay? Dito ang basis ng dissociation constant mo. If ever na equal to or more than 0, this will be considered as a strong acid. So, another example, halimbawa, meron tayong sodium hydroxide in water, and after dissociation, kung mapapansin nyo, no, kukunti lang yung nag-dissociate. For example, in this picture, isang molecule lang out of the 3 molecules of sodium hydroxide yung nag-dissociate. So, this will be considered as a weak base. Okay? Ibig sabihin ng weak base, it is hard to dissociate. And kapag kinompute natin ang dissociation constant ito, it will result to less than 0. So, for example, for the computation of the dissociation constant of sodium hydroxide, so again, you have to take note of the contents of your sodium and your hydroxide over the overall contents of the sodium hydroxide. And for example, no, ang nakuha mo is 10 raised to the negative 15. So, yung negative 15 will be the basis of the dissociation constant. Kung negative 15, ito ba ay strong or weak? Siyempre, ito ay weak base. Dahil ang ating basis is dapat less than 0 ang exponent to be considered as a weak substance. Okay, last of the biochemistry recall is the definition of your pK. And pK is actually or simply the negative log of your dissociation constant or the ionization constant na kanina natin discuss. So in formula, pK is equal to negative log of the dissociation constant na kinocompute usually by taking note of the contents of the substance. And by theory then, this pK is also known as the pH or the power of the hydrogen. So ito usually ang focus ng ating discussion for today. So ano ang significance ng computation of your pH? So halimbawa, no, if you want to dissociate a weak acid, okay? So paano mo 'yang gagawin? So again, balik tayo dun sa ating theory na you can dissociate the acid by releasing the hydrogen ion from the water. And through this process, you have to raise the pH above the dissociation constant. Correct na lang yung ating handout. Okay? By raising the pH, you can now easily dissociate the acids. Specifically, yung mga weak acids natin dahil ito yung mga mahirap ipaghiwalay. So, same goes with our bases. Okay? Si base ulit, ano ang kailangan natin i-release? The hydroxyl ions. And in this process, it is the other way around. You have to lower the pH below the dissociation constant in order to easily release the hydroxyl ion from the substance. Okay, normal values, and these are must-knows, no? Kung darating man ng araw na magme-med kayo, kakailanganin nyo rin na tandaan tong mga values na to. So, for our RR, what is RR? This is, so let's start off with our first value, the RR or respiratory rate. So, ang range natin dyan is 12 to 20 CPM. CPM means cycles per minute. Ang ibig sabihin ng cycles is natapos niya yung inhalation and exhalation. Okay? Doon mo palang bibilangin yung breath niya. So, yun, per minute, ito ang range ng normal patient. And then pH naman, it ranges from 7.35 to 7.45. Walang unit na kailangan kapag pH ang pinag-uusapan. Sa PaCO2 naman or arterial pressure of carbon dioxide, 35 to 45 mm mercury. Para mas matandaan nyo ito, tanggalin nyo lang yung 7 ng pH, no? 35 to 45 yung value. Next naman, arterial pressure of oxygen ranges from 80 to 100 mm mercury. While yung saturation of oxygen in arterial blood naman ranges, ang natin is more than 95 but never will meet 100%. Bakit kaya? Kasi ang oxygen is also a source of free radicals. Okay? Pag sumusobra ka rin ng oxygen sa bloodstream mo, it will be converted into reactive oxygen species or tinatawag natin free radical, which is a lot more dangerous sa katawan than beneficial. So, ang range natin dyan is 95 to 99. Okay? And then, bicarbonate naman ranges from 22 to 26 momols. No? Some of you will read this as momols. Okay lang naman, but in scientific community, it's millimoles per liter. And for operational definition, So, ano ulit ang ibig sabihin nito? Paano natin i-measure yung isang term? Okay? For acidosis, to operationally define this, the blood pH is supposedly less than 7.35. Remember, ang ating normal value is 7.35 to 7.45. So, less than 7.34 ang term natin for acidosis. While alkalosis naman, mas met ang pH of more than 7.45. And babalikan natin the pH. How to compute for that? It is the log of 1 over the concentration of your hydrogen or the negative log of concentration of your hydrogen. Kaya tinawag siyang pH kasi ang focus natin is the concentration of the hydrogen. Okay, balik naman tayo sa mga buffer system. Back in biochemistry, buffer is defined as the combination of a weak acid plus salt or conjugate base. Okay? So, kailangan natin ng buffer system to maintain the homeostasis of the blood pH or to maintain the normal value. Kaya tayo merong mga reference ranges. Kailangan ng katawan ninyo na i-maintain yung bodily processes by maintaining these normal values. And to help the buffer system, meron tayong tatlong major processes. So, number 1 dyan is the most commonly used by our body is the bicarbonate carbonic acid system. Next naman, primarily by the kidney, is the phosphate buffer system. And lastly, the buffering process done by your plasma proteins. And again, this buffer system is to regulate and maintain the blood pH by maintaining the levels of the hydrogen compound. Unahin natin ang bicarbonate carbonic acid buffer, and in this system, the weak acid is the carbonic acid. The salt or the conjugate base is the bicarbonate. So, the combination of this will be the buffer system. Okay, halimbawa in this situation, halimbawa lang marami kang alkaline sa katawan or madami kang bicarbonate. So, ano ulit ang gagawin natin? Kailangan natin i-lower ang pH by adding the hydrogen compound. Okay? In the combination of your bicarbonate plus the hydrogen will result to carbonic acid. Pero hindi pa dyan final. Okay? The carbonic acid will be degraded into more or less dangerous compounds. So, anong mga less dangerous compounds? The water and the carbon dioxide, which can be easily excreted through exhalation. Okay, next example, halimbawa masyadong ma-acid naman yung ating blood or acidotic ka. So, ang kailangan natin is to raise the pH by adding your hydroxyl compound. This combination will produce a lesser dangerous compounds such as your water and your bicarbonates, which is both can be excreted via kidneys through urine. So, nabanggit ko nga kanina, this is the most common type of buffering system. And ano kaya yung mga advantages of this system? So, unahin natin that the byproducts of the metabolism can be eliminated easily by lungs and through urine. So paano yung elimination by lungs? You can modify the pH by modifying your RR. And again, what is the normal value of your RR? 12 to 20 CPM or cycles per minute. So, paano niya nababago ang pH? So, ang sabi, no, respiratory rate is directly proportional to pH. Kapag, halimbawa, no, more than 20 yung breaths mo per minute, so you can alter that, you can alter your pH to a direct effect. So, mas mataas na RR, mas mataas din ang effect dun sa pH. Mas mataas yung levels. And again, no, nabanggit ko nga kanina that the byproducts can be eliminated through urine. So, pwede natin i-adjust yung paglabas ng bicarbonate and water through the kidneys. So, next, hemoglobin as a buffer. Diba? Hemoglobin is also part of your plasma protein. So, paano niya ginagawa yan? So, bago ang process na yan, no, yung ating deoxyhemoglobin, yung wala pang oxygen, will exchange the hydrogen from the hemoglobin for the oxygen. So, mag-exchange yan. Kukunin yung oxygen, ibibigay niya yung hydrogen sa lungs. So, we have to take note that hemoglobin is the most common plasma protein that can be used or that can act as a buffer of your blood pH. So, first, hemoglobin will try to get its oxygen from the lungs, no? And then, it will form the oxyhemoglobin to be distributed towards the peripheral tissue or the organ or the target organs. So, kapag dumating na yung oxyhemoglobin sa peripheral tissue or target organs, it will exchange the oxygen for the hydrogen para ma-convert na siya into deoxyhemoglobin, and at the same time, pupunta ulit sa lungs to repeat its cycle. So, ganito mine-maintain ni hemoglobin yung hydrogen compounds sa ating bloodstream. So, recall lang natin, we have two types of hemoglobin, okay? The deoxyhemoglobin and oxyhemoglobin. Pag papunta sa lungs, deoxyhemoglobin form muna siya. Wala siyang dalang oxygen. To get its oxygen, it will exchange the hydrogen ion for the oxygen molecule. And it will be converted into oxyhemoglobin now. So, pupunta ulit niyan sa mga peripheral tissue or target organs. Ibibigay yung oxygen dito sa mga tissue na to in exchange with hydrogen. And then yung hemoglobin na yun will return to its deoxyhemoglobin and the cycle goes on. So, discuss din natin yung mga not so common buffer system but really helpful, lalong-lalo na if may mga damage sa ibang parts ng katawan natin. Halimbawa lang, may damage ang ating lungs. Sino ang kikilos para sa ating buffer system? Primarily, it will be the kidneys. And one of the processes in the kidney is the phosphate buffer system. Ang main goal nito is to exchange your sodium for the hydrogen ion. Okay, medyo malilito tayo. Bakit phosphate buffer ang tawag pero sodium and hydrogen ang exchange? It is because of the binding of sodium and phosphate ions sa ihi or urine. So, halimbawa in this picture, acidotic ka or madami kang hydrogen ion sa bloodstream. So, in exchange, no, in exchange of hydrogen ions, i-excrete mo yan sa urine, and then yung sodium na nakadikit sa phosphate, ibabalik mo sa bloodstream. Kasi kailangan may give and take dyan. No? So, kailangan may exchange na nangyayari. So, next are your plasma proteins. As discussed earlier, no, the most common plasma protein for buffer system is hemoglobin. And aside from that, mayroon pa tayong other plasma proteins such as your immunoglobulins, myoglobulin that has negative charge. And again, as the famous rule implied, no, opposite attracts. So, ang negative charge ng plasma protein is capable of binding the hydrogen which has a positive charge. And lastly, your chloride shift. And chloride shift happens in RBC. So, paano yan nangyayari? So, halimbawa, this is your RBC. Okay? Meron tayong nangyayaring exchange of your carbon dioxide and oxygen to form your deoxyhemoglobin and or oxyhemoglobin. So, aside from that, yung role ng ating hemoglobin, may role din yung chloride shift. And chloride shift will exchange your chloride with your bicarbonate naman this time. So, papasok si chloride sa loob para ma-release yung ating bicarbonate from the RBC, making the blood pH a little higher than normal. So, dito naman tayo with the classification of the systems of acid-base. So, unahin natin yung respiratory component. Sa respiratory component, the responsible organ is the lungs. And lungs control the amount of dissolved carbon dioxide in blood through exhalation. And then another component is the non-respiratory or tinatawag natin in other books, metabolic component. The responsible organ for this part is the kidneys. And kidneys control the amount of bicarbonate in the bloodstream. Through, yun nga, i-convert niya yung urine mo into acidic or alkaline. So, paano ang balance ng pH using these two organs? Unahin natin ang lungs. So, sa lungs, sabi nga natin, it can control the amount of carbon dioxide, no? By changing the respiratory rate. Naaral natin kanina, right, that RR is directly proportional with your pH. Mas madami kang RR, mas mataas ang blood pH mo. And in this system, it can change your blood pH within seconds. Mas mabilis yung modification. Okay, dito naman tayo sa lungs. Aside from controlling the amount of bicarbonate in your bloodstream, it can also control the amount of ammonium ions. And in this example, no, halimbawa lang, acidotic ka, you can excrete ammonium, you can retain bicarbonate. And dito naman, mas matagal yung modification. Okay? It will respond within hours to days. So, example lang ng ating situation. Halimbawa, ang blood pH mo is less than 7.34. You are considered as acidic. So, si lungs, ano ang gagawin niya to modify this blood pH? It will start hyperventilation process. Kapag hyperventilation, di ba, mas madami kang breaths per minute. So, mas mataas ang RR. Therefore, you release a lot of carbon dioxide. So, therefore, the acidic pH will turn into a much more balanced pH kasi na-release mo yung carbon dioxide sa bloodstream. Dito naman tayo sa kidneys. Halimbawa, acidic ka ulit. Okay? So, ang gagawin ng katawan mo, through urine, it will excrete ammonium ions. No? Therefore, ano ulit ang chemical formula ng ammonium, di ba? NH4. So, sa hydrogen ng NH4, no, it will be released out of your system, out of the urine. So therefore, yung bloodstream mo will have a balanced pH. Okay, other way around naman. Halimbawa, basic ang ating blood pH or alkalotic. So, anong gagawin ng lungs natin? So, it will start hypoventilation. Ano ibig sabihin ng hypoventilation? Mas mababang respiratory rate, less than 12. Okay? So, hindi ka masyadong nag-exhale ng carbon dioxide mo. So, it will you will retain or there will be a higher retention of your carbon dioxide. So, patataasin yung blood pH mo. Yung basic pH mo dati, magiging normal na sa ngayon. Si kidneys naman, ano ang gagawin niya kapag alkalotic ka? So, sa ihi mo, palalabasin niya yung bicarbonate. Okay? So, therefore, yung ammonium ion, ma-retain. So, yung mga NH4 mo, okay? So, yung hydrogen sa NH4, ma-retain sa bloodstream. Therefore, yung basic blood pH mo dati, magiging balanced na or normal blood pH na. So, balikan natin yung topic sa biochemistry nyo ng Henderson-Hasselbalch equation. And this equation tackles the computation of your pH based on the following information: the pKa and the log of the contents of your base plus the contents of the acid. Yung Ca dito is the levels of the base and yung Cha is yung levels of your acid. So, balikan din natin yung normal ratio of the acidic compounds and basic compounds. To maintain the blood pH of 7.35 to 7.45, the compounds in our bloodstream should follow this rule. So, halimbawa, ang ating bicarbonate ay meron tayong normal value na 22 to 26 millimoles per liter with an average of 24. DCO2 or dissolved carbon dioxide, ang average niyan is 0.0307 and the arterial pressure of carbon dioxide, ang normal range nito is 35 to 45 with an average of 40. So, dito na-derive yung formula ng ating normal ratio. Okay? So, kukompute natin yan. Multiply muna natin yung denominator. So, 1.2. 24 divided by 1.2 is 20. And the normal ratio now of your bicarbonate to your carbonic acid is 20:1. So, break muna kayo and come back with our second part of ABG and gas exchange lecture.